For my project, I chose to do a site selection analysis on where to put a new high school. In my home county, in Arundel County, all the high schools have been overcrowded and just have very high student-to-teacher ratios. So a lot of people have been suggesting that a new high school be built to house more students. I chose to do an analysis based on where this new high school would go. The 5 initial factors I considered were the potential for sea level to overtake this new high school, the average October, January, and June temperatures representing the seasons that take place during the school year, and then the potential student population where higher populated areas are favored. After a scoring scheme is made to rate sites, a network analysis would be performed to find how many students would be in this new area and how many of them would be unique to this new school. So for my first couple factors, I chose sea level rise. Because if you're going to build a school, you want it to be there for a long time. The way I scored it was basically if something was lower in elevation, it would get a lower score. So areas within 5 meters of sea level or 5 feet of sea level would get a very low score, while areas 5 to 10 or 10 to 30 would get a higher score. Areas above 30 got the highest score, and it goes all the way up to 2,000 because very few people suggest that the entire ice cap will melt and produce a sea level rise of that magnitude. Another factor I did is the student population. Now, the census block data I used was it did not break things down exactly how I would have liked. It had 10 to 14 and 15 to 19. So I kind of had to use 15 to 19 as a proxy for high school students, but it approaches about the same. But from this map, you can see there's more students in the south and the northeast of the state, leading to areas where it'd be more beneficial to have a high school to serve more students. And I basically did a natural breaks classification to split those into 5 categories based on the distribution. The 3rd, 4th, and 5th categories I did was I took the weather station data from the NOAA website, performed a inverse weighted distance analysis or interpolation to produce a raster of temperature, and then separated the temperature into 5 different classes, with the more mild areas being mild defined as being closer to 72 degrees, getting more points. So the cutoff being 72 degrees really comes into play in the June temperatures, where the highest class was about 72 to 75 degrees, which is a bit warmer than that cutoff. So it could get on higher than average days hotter and be less beneficial to students. So once I combine all those maps, I produce this map on the right here, where the greener an area is, the better the site is for the area is for a new high school, and the redder it is, the worse it would be. There weren't many very green areas, so I chose to put 2 in very green areas, 4 in a couple green areas, 3 in yellowish areas. And then this one right here I actually looked it up, and that's the actual proposed site of the high school that people want to build. It's being built in a year or 2. And I just decided to throw it on there to see how my scoring scheme and how well placed the actual high school was going to be. So to find out how many people would be in these zones, I decided 5 minutes would be a reasonable amount for people to drive. So I did a network analysis, made a service layer, added locations to it, and then solved to produce these zones on the left. But to find the unique student population in this area, I first had to subtract the current networks, because otherwise there'd be some overlap and you wouldn't know if an area had 200 unique students or 2,000. So to do that, I made the same 5-minute drive for the current high schools. After that, I did a union with the proposed high schools and did a select by location, where the selecting by location would give only the areas that are unique to the proposed sites. And this one's spatially joined with the and Arundel are the census tract data for the 15 to 19-year-olds produced the map on the right where a greener area it is, the more high school students it has, and the better it would be for a potential site. These results actually surprised me. I expected areas my scoring algorithm liked, like the southern area or these areas here, were kind of middling at best, and even in the south it was bad. My kind of initial thought was maybe there's more space, so they might have more people there. But it kind of turned out that you need, even if you have a small area like you do here, where it's squished in between a lot of schools, or like right here on this peninsula, it's you still get more people just because of the population density. Ironically, the best performing school was the site they chose, was Crofton High School, or Crofton area, even though my scheme didn't really like that at all. And kind of just some reflection was, I think mostly what I did wrong was I did a lot of put too much emphasis on environmental factors that people kind of only think about in like long terms, as opposed to more demographic factors like income or structural things like infrastructure that would better predict where people would put a school. Also, the environmental factors, I put too much variance where a difference between a class that has 1 point and a class that has 5 points could be maybe 5 degrees, which is hard to feel on the ground. But this does show that that GIS professionals do go through this every day, make complex choices, factor in a lot of different factors to make these decisions that they think will be best for the community. Yeah, that's my project. Thank you.